So yeah, event sourcing with Commanded. Up until a couple of weeks ago, had zero experience with event sourcing, but a recent Elixir project brought up the possibility of having event sourcing involved. So undertook a bit of learning to understanding what it is and how it could be implemented. Oh, can you hear me? Is that something? All right. So this talk is an overview on some of the things that I've learned on event sourcing, a concept called command query responsibility segregation, which is also referred to as CQRS, and how a framework called Commanded can be used to help implement event sourcing in Elixir. I'll provide links to the resources and the tutorial I used to learn about event sourcing on the last slide. Recommend anything by Martin Fowler or Greg Young. So when you start looking into event sourcing, you realize how useful it can be, but also how complex it is. And there's a bit involved with implementing it. I feel like I've only really scratched the surface with this talk. But one of the biggest takeaways I got was around knowing how, knowing the actual business this is being applied to is really important in implementing it effectively. So I'll start with an intro into event sourcing and CQRS, some examples, and then run through how Commanded helps with implementing it. So rather than just storing state, event sourcing captures the changes to the state as individual events. And those events are stored in the order that they happen. The events can't be deleted. So there's a log of how the current state has ended up, how it is. The current state can be calculated from the events and persisted to a DB or just kept in memory. The point is that the events can be replayed at any time to get to the current state, or at any point in the timeline, you can recreate the state at that time. If there's a huge number of events, you can use rolling snapshots that a snapshot can be made after X number of events. And so that would improve the efficiency of replaying an event, as you just need to go back maybe to the last snapshot and just replay the events from that point onwards. A regularly used example of event sourcing is a bank account. You could see transactions as events and the current balance is the end state. So you have different events of money being withdrawn, money being deposited or transferred, and you have the end result of what your current balance looks like. As opposed to only storing the end result of the balance. So if you have the transactions, if there's any discrepancies or it gets into a weird state, you can look back at your transactions or your events and replay them to reconstruct balances at certain times or at the end. Another good example from Greg Young about how event sourcing can be useful is an online shopping cart. So you could store events relating to adding and removing an item from an online shopping cart to tell the story of maybe how the end state of the cart came to be. So a business might want to report on whether there might be a higher chance that a customer would respond to a product suggestion based on the items that they've previously removed. So I guess the idea is like how past data is interpreted could change over time due to different requirements. So storing the actual events rather than just the end state could help facilitate that. Another learning is around the process of working out how you're modeling the events and behaviors and how they're named. So for example, there could be an event called change address, but is that correcting an address or is that a full relocation to another address? And depending on the business, that difference might make a big difference in how that's interpreted. So a good place to start when defining events is to work out what the use cases for the business are and then align events to those. Command query responsibility segregation. This is a quote from a programmer called Bertrand Meyer, where the principle originated. Every method should either be a command that performs an action or a query that returns data to the caller, but not both. And so when CQRS is used with event sourcing, there's a split between the right side of the system. and the query side. So the write side doesn't return any data, and the query side will return data, but it can't change any sort of state in the system. The advantage of this is that some applications may be more read intensive or write intensive. And this would allow like the system to be optimized separately based on which is more intensive. So here's a diagram outlining event sourcing with our split between the write and read sections. Let's see if I have a pointer. So you would have a client that would have some sort of action or command, and that would be handled in some way where maybe the command is validated and some sort of business logic is applied to it. And out of that is an event that is then saved or persisted to the event store. Once that has been saved, then a message would get published, and there would be something that subscribes to that message and writes to a read model or two read models or different read models depending on what the requirement is. And so what happens is the client only queries the read model and not the event store directly. And this diagram is the commanded flow, which looks really similar. So we have our write and read side. So the first thing looking at commanded is it helps you implement event sourcing with your read and write split. I'll go through each section here, but this is just outlining the different modules of commanded that are implemented to do the different parts. So I'll give more details as we just go through the flow. So starting off with the client, the context around this would be a bank account and opening an account. So here a post request is being made to the API accounts route, which takes a payload of an initial balance. This is nothing new. So there's a router which then calls a create function in the controller. And then we go to a context for accounts, which then calls some sort of function that opens the account. At that point, we have a command, and that's represented as an Elixir struct here. It's always in the imperative. So example, add funds or open account. The next part is the router. So the command goes through a couple of things. So there's a module or a macro called middleware, which can be used to validate the command before it's dispatched further on. The middleware macro can be used to validate things like is the account UID in the right format, or is it a positive integer? And you implement it via a module which has a behavior commanded middleware, and you have a before dispatch. So that'll be done prior to it going further on. And this is where we could do some sort of validation on the command. And then there's after dispatch and after failure. So you could do some type of logging at that point. And then you have the router, and there's a dispatch macro, which we have our open account command, which goes to our account aggregate, which I'll explain in the next slides. And so we're at this point here where we have our command and what's called a aggregate and our event store. So the aggregate can enforce business logic. So it could check that the account doesn't go overdrawn. And after doing that, it returns an event, and then that event is persisted to the event store. At this point, Commanded does a ton of stuff in the background. So when you're implementing this, you get to this aggregate stage and you put an execute and apply function, and you don't really know what's going on in the background. So I added a couple of io.inspects to log at certain points or where things were happening. Because in your terminal, you'll see there's a lot of logging that shows up to show you like an event being dispatched and acknowledged. And so from this point, it gets a bit grey as to what is going on, but the two main functions in the aggregate module that you need to have is an execute and apply. And here we're pattern matching on the command coming in and the apply pattern matches on the event. So the execute enforces any sort of business logic. So here we're checking that the initial balance that's coming through when they open an account is greater than 0. And if so, then it returns an event. And then the apply function updates state and persists the event store. But yeah, in the background, as I said, there's quite a bit going on. So looking at the source code, what happens is this aggregate is actually a gen server process, and it has a execute function and apply and persist events function, which seems to line up with these two here. And it adds the event to a stream, and then it persists it to the event store. And then at that point, a recorded event is emitted to which our projectors, which I'll go into next, can subscribe to. But yeah, there's a hell of a lot going on in the background there. I'll link a README that I put together of all the sort of investigation I did into what parts of Commanded are actually doing what based on the logging. So an event is an Elixir struct, and it's a fact. It's in the past, so it's funds added or account opened. So yeah, after the events are persisted to the event store, as I said, there's a message that's published and things called projectors listening to those. There's a module called, sorry, excuse me. Commanded projections ecto that we're using in this example. There is also commanded event handler, which I haven't implemented or had time to look into, but it's another way of handling the events. And I think that one of the differences is that it gives you a bit more freedom to implement how the event's being projected or stored. So if you're using commanded projections ecto, you need to use a Postgres database or MySQL, or something that's compatible with ecto. So here we have a projector. And what this does is it has this project macro, which pattern matches on the event. And I'll show you the code after these slides, but you add these projectors to your supervisor as workers. And so they're running in the background, waiting for those events to come through. And when the event comes through, it does an insert into an account table, which has the account ID and the current balance. And that's also a Postgres DB in this instance, which is our read model. So I'll just show you the code. Can you see the codes that can you still see the screen? Okay, yep. Cool. So yeah, so stepping through the whole flow that we just went through, we have our router, which has our accounts endpoint, and we have a create function here, which calls our open account in our accounts context. Here we have our command that we've created. There's two things happening here. So we have our struct. We're also using a library called schema, which helps with validating our command. So here we're providing a schema and saying we're using a regex to validate the account ID. And then we're checking if the initial balance is a positive integer. And this is our context, and this is where our router dispatch function is happening. So we alias our commands, and we're just generating a UUID here, and that goes to the router. And this is where we see our middleware, which is before the dispatch is called. And that module looks like this. So we have our behavior, which has the before dispatch function and after dispatch and after failure. So we're looking at the command and the struct and checking and calling that valid function that I showed you previously. And then this is the aggregate. So if that's all good, we go to dispatch and we have our open account command. And then we have aliased our aggregate module here. And this is where those execute and apply functions are. So if I just go to the top and show the open account example. So we have a couple of execute functions here, but we'll pattern match on open account, and it'll check initial balance. Has the account already been opened? Has it been, yeah, so it's already been opened, or where is it here? Yeah, so the initial balance is at greater than 0. And this is the event that is emitted. And if we scroll down, there is a apply function which pattern matches on that event and updates the state of the account. But in between that happening is where all this stuff happens in the background, where the event gets persisted to the event store, and messages are published. And this is just the event struct. And this is the supervisor. So here we have our projectors that are supervised. And this is those projectors waiting to listen to the event of account opened, or withdraw money or deposit money. So I left out all the config, but overall if you cancel out the router, the controller, and the context, you kind of have like 4 or 5 modules to set up to get this running. And as someone with limited experience, it helps with just getting an idea of the flow. I'm not too sure if anyone's actually implemented, I'm sure people have, but like how it's implemented without any sort of framework. But yeah, it seems like it's quite a handy framework to use to get up and running with event sourcing. And yeah, that's it. So I've just linked some resources in the last slide. So the tutorial, this paper that Greg Young's written on event sourcing that was had a lot of detail in it, and also the slides and that README that I was talking about is in my GitHub here in Commanded Learnings. And that's it. Thank you very much.
Awesome, thanks, Fee. Has anyone got any questions for Fiona?
Yeah, I've got one. Do you use this sort of in any real world projects, or has it just been playing around with it?
Yeah, on the Commanded side, apparently it is being used in some real world projects. I'm not too sure who the companies are, but yeah, there is a few companies using it.
Question for the audience: has anyone used it in production?
Not Commanded, but we've used other event sourcing approaches at work. And yeah, the pattern as a whole is good. If you pick the right use case for it, it can be kind of heavy for doing it for everything, but for the right thing, it makes a lot of sense.
Yeah, I mean, we've rolled our own where we've needed it, but Commanded looks like it, a decent framework for at least thinking about it and investigating it. I'm not aware of anyone that's used it in production, so I do wonder how appropriate it is, but
Yeah, we're kind of very similar. We did one in Elixir that was hand-rolled, mainly because we only cared about the projection side. We're basically consuming events from a different system, so it didn't need the whole shebang that you get from it. But I think I'd probably reach for Commanded if I had to do like a full application built using that way.
The author of Commanded has given a few talks at the Elixir London meetups about it, and I know there's a few people using it in production in London, but I can't remember who. They just said, "Oh yeah, I'm using it," and asked technical questions that I was just like, okay, cool, you're using it.
Yeah, I've done some work with event sourcing, not with Commanded. And yeah, I've found there are those benefits of not storing state in one place and being able to replay events. It's also made debugging and testing a lot easier. I've found that, you know, keeping trace of or keeping track of changes to reasonably complex state can be a lot easier if you're talking about quite atomic changes. So writing tests for those sort of changes to state is a lot easier. Yeah, so I mean, and I think Commanded seems to be geared towards the whole of business approach. So it looks like you would be, you know, implementing a lot of your business logic. You can just do event sourcing in, you know, the places you think it fits. And that's how I've done it before. And it's been, yeah, been quite successful.
CultureAmp's been using event sourcing kind of all over the place. And we've been using it mainly as a way of generating projections that you wish you had of the data that you've got. Because often the data that you've got is like some legacy system that somebody wrote 8 years ago and you hate it and it's in the wrong database, like Mongo, and you wish it was in something sensible. And so there's been quite a lot of that happening, and it's been quite successful for that. Not a lot in Commanded though.
I think it's worth pointing out that if you're considering doing event sourcing for a new project, maybe do it on one little piece first to see how it goes. Try before you buy, and commit to the whole thing, because we've certainly seen architectures where you've gone all in before you really understood what the implications were, and it didn't work out so well.
I think it really works well where you've decided that you need microservices. That's just my 2 cents worth. It's probably not a very good 2 cents worth.
Yeah, now that when we've used it, it's been mostly for money things. Keeps the finance people happy. They have a record of all the little bits and pieces and not be splatting state and randomly updating things and losing data. Not losing it, but you know, you don't have the record. If you do an update or you do a delete, the data's, you don't have the state that it was prior to that transaction happening. So yeah, the from an auditability point of view, the finance people love it.
How much more complex is it, like, to use event sourcing in the cases that need it? Like, how much more complex is it compared to, yeah, just a normal architecture? Like,
more than you think.
Yeah, it's quite a lot. I'd say at least double, maybe an order of magnitude more. Like it's, yeah, there's quite a lot more. So it's a non-trivial investment to make. So for the cases where it's a good fit, it's great. But for everything, it's going to be overkill.
Jeff, I think it also, you need to consider how much effort. Look at the domain that you're working in and say, will I ever need these things? Will I ever need to know the full event history of this thing? Because retrospectively trying to do that is, well, nigh impossible. So it might seem like a lot of work up front, but in the long term, it can end up being quite a lot less.
I think you also get a lot of stuff for free that you don't get from if you're just storing state. So if you're just mutating state in, say, a DB, and someone in the business comes along and says, oh, what happened at such and such a time? If you're doing event sourcing, it makes it almost trivial to be able to pull out a projection. And I think the point David made about being able to have different projections of the same underlying data is really handy. So you're not sort of tied to going, oh, I want to pull this record out and that's the only way I can view that data. So you get that sort of ability to go back and show people what's happened. And that can be, whether it's finance or sales or any part of your business, that can be really handy to see the history of how your your data got to that state, and that can be mined and used for dashboards and all sorts of stuff. So I think all that, once you get it in place, can be really handy. I think also Commanded is like gold-plated event sourcing. You do not have to go down that route of having, you don't have to have projections really if you don't want to. You can do things on the fly, and that's how we started. And we just we did end up having, every X thousand events or whatever rolling up sort of intermediate state, but it looks like there's a fair bit of overhead in Commanded. You can start off a lot simpler and still get a lot of benefits, I think.
Yeah, one thing that I've seen is that a lot of people end up rolling their own framework for it. So that's why maybe there's not so many people that have necessarily used Commanded in production, but they have used event sourcing. As it tends to work out that if you're using Phoenix or you're doing like a web app, the framework itself is most of the logic, like serving up web requests and passing them, and all the magic that goes on there. That's a lot of code. Whereas with event sourcing, the actual framework is relatively small, but your application logic is huge. So a lot of people think, well, I'm just going to roll my own, and a lot of the times that's not a bad thing. Like you wouldn't roll your own Phoenix, but you could roll your own Commanded if you've got a smaller use case and it makes sense for that.
So about 3 years ago, there was a project at Alembic, and Commanded did exist, and we did investigate it. And at the time, I can't remember all the reasons. I think it wasn't super well documented. There weren't many tutorials around, and it had a lot of concepts in it, which were deemed to be superfluous to requirements at the time. But that could have also been because of a naive understanding about event sourcing. So we ended up rolling our own, and it actually worked pretty well. But it was fiddly to get it right. It's like, you can understand the general abstraction, but the nuances and the details. So yeah, I'd definitely, if I was going to do it again, I would reach for something like a framework and try and use that. But it's definitely a tractable thing to do your own on a certain level of scale and complexity, I guess.
What's the general approach if your event originates outside of your system? So you might actually be passing through like a series of microservices. So you actually want to get an overall view of that event as it's come to you and then passed through you. Is that easy enough to kind of extend Commanded to include like some sort of a UUID or something like that you can sort of trace things through multiple services?
Yeah, from memory, it tracks like a correlation ID or a causation ID on there. I think the general kind of practice is to not do that so much. Like if you've got events that are passing from one system to another, you kind of keep, within the domain of one thing, be all the events there. I've worked on projects that had different services that pass events back and forth, and that kind of gets confusing quickly because you need to be a lot more formal around what the event structure is and how it's the contract for that sort of thing.
That's probably a good thing anyway, surely.
Yeah, which is not a bad thing.
Yeah.
But a lot of the time, like when I've seen
Sounds like more work though.
Yeah, when I've seen event sourcing work really well, it's like within one app. And effectively the events are like an implementation detail inside that app. Then you've got a sort of different thing where if you do have like an event-driven architecture where you do have events flowing from one system to another, you can totally do that there, but you're kind of using slightly different patterns for it in that case.
But I mean, in direct answer to the question, I mean, surely it's just another piece of data, and then you can do with it what you will.
Yeah. I mean, I think you can just have events passing out of there, and you could stamp something on there, and maybe that's getting into more what telemetry does, but
yeah, maybe
kind of tracking the spans of like microservices responding to different parts of the different operation. But yes.
Yeah, I guess I'm asking the question because in some cases I think it would be useful to understand what potentially triggered the event. Obviously then being able to replay that event's important, but what caused it to initiate I think might have some value.
Yeah, I think there's like, I can't remember if Commanded does this, but you can have like a causation ID or a correlation ID, or both, that kind of tell you where this thing originated from, or if it's part of something else, or give you a little bit of tracing like that.
And then off to your logs you go.
Yes. I mean, correlation IDs are are more, I mean, are kind of outside the scope of event sourcing. I mean, they're used widely within microservices, etc. Well, they should be more widely.
One of the things we found tricky with our event source system was that there was multiple sources of events that would contribute towards a projection, and depending on like upstream delays in the network and availability, you can receive events out of order. And if you have logic that reacts to the result of a projection to then perform further logic and do stuff when it gets into the state, you've got you need things like sliding windows of like, okay, it looks like it's stable now. You can end up in situations. So we had multiple upstream sources of data that we could definitely see things that happened we would see it not in the temporal order of how it actually happened in reality. And so the projection, while the projection is easy to rebuild in the order of events, you've got to kind of, you don't necessarily put the order of events in the order that you receive them, but in the order that you should have processed them. And so there was definitely subtleties around there. And distributed systems are hard, with whatever mechanism you pick.
So was this, I'm not sure this question was asked before, but is Alembic planning on using Commanded now?
So we were using it in a prototype for a system for a project that might not actually pan out. So we'll see. Well, we're thinking of using it that Fiona's working on. I was hoping Fiona would chip in and answer that question.
Yeah, no, it was just some research, to be honest. There was potential for event sourcing to be involved, and myself and another dev had no experience in it, so we spent a bit of time doing some learnings around it. And we found the Commanded framework, and it was a good starting off point to learn about it, because I think when you're coming from a place with zero experience in it, at least for me to learn it, I need some sort of context in how it all works and some sort of flow. So yeah, it really helped with that. But yeah, no, it's not currently being used.
I can't imagine in some of these smaller examples that there'd be much of a performance penalty though, but in a larger system, would you say that this would add a layer or a significant layer of performance, or perhaps cause you to maybe architect slightly differently to handle that additional load?
Yeah, I'm not sure, to be honest. Sorry, I don't have the experience. Maybe someone else.
And yes and no, because it depends on what you mean by performance. So there's going to be more overhead potentially in writing, but because you have CQRS, you can split your reads out. So you can build a projection that's very, very fast for reads. So if you've got something that's got relatively small to medium number of writes, but a huge number of reads, it can be good for that, because you can scale the reads on that. So the projections could be, just built into a database, or they could be, in memory, or that could be spanning off to some other fancy NoSQL database or whatever. And so it kind of lets you scale that stuff outside of it. So one of the things that we've done at work is we basically have updates that dribble through, and then the projection then gets pumped out into Elasticsearch. So we're using event sourcing to build the search index. And then we've got a Elasticsearch cluster with however many nodes in it. So in that respect, you can kind of scale that really easily. You might have more overhead on the writes depending on how you do it. Like, I think the interesting thing with Commanded is it uses like a gen server actor for each aggregate, which is kind of cool. But yeah, there's some overhead in keeping that around as well. I think it does hibernate them if they haven't been used for a period of time. But I've used other frameworks like in Ruby where it would effectively kind of not keep anything around. So anytime you got a new event, it would have to load all the events from the previous aggregate into memory, or it'd have to snapshot and do some work on that. And yeah, that could be kind of heavy.
Yeah,
You-
so
you-
we noticed that on the project a few years ago, the event source project, that building the projections got expensive, and we would have to do some caching to avoid having to rebuild it from scratch every time we needed to use it. Wasn't huge. One of the other issues is that like rebuilding the projection sort of becomes like a bit of state, and if you've got multiple machines behind a load balancer, like and you need to rebuild, you might end up needing to rebuild the projection more than once. It could get wasteful, so you might need some caching, but then the caching gets hard because you've got to make sure that you've definitely cached up to the events that you've seen, and then you have to apply deltas, and it gets a bit tricky. But yeah, it's all tractable stuff, but there's just a few things you need to think about.
Was it obvious where that expense was being incurred, where that cost was? I mean, or did you find that you had to sort of benchmark your way through the event sourcing to figure out what it was that was, giving you some impact?
I can't remember all the details because it's quite a while ago. But I think we first noticed the pain in a bunch of unit tests that started to get really slow. So we were so first of all, it was like, how do we make our test suite faster? And then that improved that, but we also did notice it in production as well. When there was a lot of things going on, it got expensive to rebuild that projection on every received event. We were essentially building deriving a dashboard from a projection, and it would be quite expensive to build that every time we wanted to render the view. There was a noticeable delay, and so just trying to keep track of essentially your cache key becomes some kind of hash of all the event IDs you've seen so far to the actual result of the projection, and then you have to reconstitute that. You can deserialize that cached version and then apply the events that you haven't seen that you've seen since you cached it on top of that, and it gets a bit cheaper.
Yeah,
That's interesting.
It's a little bit of how you approach it as well, because you can, depending on the data structures you use and how you store things, you're effectively treating the projection as a denormalized or materialized view, really.
Yeah.
So yeah, if you've got stuff in there where it's basically just doing an update to something on there, like, if you've got stats that you're keeping track of and you're just adding, an event came through and we sold $100 worth of stuff and you have a running total there, you just say new total equals old total plus $100, then that's what you'd write, and that's all you need to read out. So it kind of depends on what you're doing and how you're doing it.
Just from an operations perspective as well, Julian alluded to, in that you can optimize if you have different paths for read and write. You can actually optimize quite dramatically. So they're often reading and writing from database, for example, they conflict. They directly conflict. So having that separation means that you can optimize each system for whatever it's required to do, and that can give you quite significant performance gains.
Question for Fee, the actual presenter here. How did you find using the structure of Commanded? One of the things I didn't like about it when I looked at it was it looked like you had to follow its patterns or building blocks pretty exactly to actually get anywhere.
Yeah, it took ages to get an understanding of what was going on. So even following a tutorial, like just implementing an open account flow took like a long time because I didn't really understand the terminology. So it was a matter of reading back and forth. But then, it took a while to get to a point where you understood the flow of what was going on. I also found it hard that I didn't know exactly what was going on in the background, and it kind of magically happened. And that's why I kind of just chucked a bunch of logging in so I could see at what points things were being called and see what there were like a bunch of debug logs that would output some text, and then grabbing that text and doing a global search in like the Commanded source code, and just to see exactly what was being called when and why and how that all worked. But yeah, it did take a while to understand.
Do you think you ended up with a better result than if you'd gone down the roll your own path? Or
yeah, I mean, I haven't gone down that path, and that would be like the next step, to be like, okay, well, how would I implement maybe a simple event sourcing flow without using a framework?
Okay, cool, thank you.